Okay, I am back again to work on my Elf Dumper. I took a week off from streaming just to focus on Bin Dash and stuff, but we're all set now to get back into the Elf Dumper. Elf is a pretty simple format overall. I mean, there are parts of it like Dwarf, which exists within the Elf file that are not simple. The exception stuff isn't going to be simple. Stack unwinding is Dwarf again, all that stuff. So that stuff's not simple, but the main structure, the part that's actually the ELF format and not the data, not the sub formats within it. The ELF part is pretty simple. We did the header last time. We should be able to wrap up today, I think, because all we have to do are dump sections and segments. There aren't, like in the PE dumper, I don't know if you've seen any parts of the PE dumper, there's like the header and then an optional header and some data directories, and those data directories all have their own stuff. So the ELF, or the PE cough format is a lot more involved. The ELF format's simpler, but we might not finish today because we do have a shortage of useful samples. We only have one sample right now, and it's an executable file. We don't even have a sample object file, so we need to build out the rest of the dumper that we can with this sample, and then work on our suite of ELF binaries for testing purposes, and make sure that we've covered features there too. So maybe 2 days once I go and do that part, the coverage completeness. That might even add a couple more days, well, depending on what it uncovers. But for now, I think we're just gonna sort of sit down and plug through some of this dumping. I'm gonna put on some chill music and get to work on that. If anyone's got questions or thoughts about the project or other projects, the Bin Dash stuff or anything, go ahead and let me know. Don't mind the interruptions today. Kind of just a chill stream to get some rote elf dumping finished. Dan asks if I've got any opinions on ELF versus PE. As far as object formats go, they're both a little bit off from what I would want, but if I had to work with just one of them, I'd want to work with ELF. Um, I think it's a little too soon to say, though. There might be things like within the relocation systems that I prefer over on PE Cough. I know for sure that I prefer the stack unwinding in the Windows land over the Linux land. Um, so yeah, I'm not sure. The dwarf part, the debug info part, I definitely don't like the Linux land stuff. But Elf itself is a very nice and simple system. So it's a little hard to say that I don't like it more. Section count times section size. Although I will say, Dan, since you create your own operating system, I feel like the object file and executable file format is one of those places where I'd love to see iteration and experimentation. Maybe when I'm done with the deep dive into ELF and PE, we'll probably do Macho at some point too, or Mako. I'm not sure how you're supposed to pronounce it, but the Mac one. Once we've done those, I could very much see me making a proposal for an object file format, and I'd be curious to see if what you think of, like, it'd be interesting to be able to use a project like yours as a test bed for a proposal like that. So if you're open to something like that, let me know, because I'll put that on the list to someday play a little more with these image and object formats and maybe design one of our own. Hey, Victor. Welcome. Alright. We need to go build that section normalizing function. Or set of functions. Pair of functions. Okay. 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 So if we get sections, we want to dump them out. So let me make sure the syntax I use here matches the syntax I used on my previous dumper. Okay, so we want to do name equals a string. Gotta get that right. I don't really know what the link field means. I need to go read the docs on that. Header align. And that's just like that, right? Null. 28 bytes, 32 bytes, 36 bytes, 32 bytes, 36 bytes, 168 bytes, 143 bytes, 14 bytes, 48 bytes, 192 bytes, 24 bytes, 27 bytes, 32 bytes, 8 bytes, 277 bytes, 13 bytes. Man, why are these all so small? 148 bytes. What exactly is it that I am dumping? I forget. Maybe I am dumping an object file. Elf test slash test. I think that's just an executable. It's executable to a lot of sections. Okay. Let's fill in the rest of these mnemonics real quick. Or let's get these all done, right? Each of these is a to-do as well. So what the name of the section. The section name's a U32. And index into the section header string table section. Section header string table section. String table below giving a location of a null terminated string. String table. We might need to pull a string table out before we can actually do this. Does the header contain the string table pointer? Is that the point? Schusternix, probably. This member holds the section header table index of the entry associated with the section name string table. If the file has no section name string table, this member holds the value shnundef. Okay. If the section name string table index is greater than or equal to low reserve, this member has the value. Okay. So in order to parse these sections, we actually need to go back and parse out a string table. I think we actually need to do this after we get the sections. Well, okay. So the thing is, right now we're just running this on the direct sections. Okay. I think that's fine. Let me just look again. String section index, so section 30. We should be able to do this. Okay. There we go. And now, to get the name, what I need to do is this member specifies the name of the section. Its value is an index into the section header string table section. Location of the terminated string. Okay, so we just need to do straight C string capped. Let's go a step farther. U8 string table first, string table one pass last. If we get a section name string table, then what we'll do is string table first is input data.string plus section name string table. Let's shorten the name of this. Okay, section 64. We want the offset. String table first plus section name not to go past string table one pass last. There's our name. And so we get an empty name interp .note GNU property .note GNU build ID .note ABI tag .GNU.hash dinsim dinster GNU.version GNU.versionr reladn reladpult init pult.got text fini row data. Yeah, this is a lot of sections. frame header frame init array fini array dynamic.got pult data bss comment .symtab .stirtab section header string tab shirstadab. Someone asked, why is the furniture floating? I don't... hold on. I can't see any floating furniture. What are you seeing? I mean, I know maybe you're confused. There is a floor in this room, but it's just not on camera. That's funny. Okay. I like it. I don't know the meme, though. You've exposed me. Alrighty. Let's track down that type string. Section type. Yeah, so that comes with an X list already. Very good. Section type comes in. We get the string back out. On our way. Okay. Straight from section type. Section type. Type null. Type progbits. Note, 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 error. Okay, error is not a real type, so that must be something I need to look into. HIOS, error. Oh man, all of these are using special codes. Okay, for that reason, I'm going to put the type code in next to it. So null is 0, progbits is 1, note is 7. That right there. What if I wanted to see this as a hex code then? Okay, let's fix this up. Cool. Okay. So there's our String types, I like that. Let's do the flags. Elf and Linux stuff always uses... They always use their flag fields and their enum fields to the fullest. They really define lots and lots of good stuff. You know? Okay. Okay, so let's see. That's 4, 8, 12, 16, 20 bits. We're going to just hard code the 20 in right here and say that the high 12 bits are set up with OS and processor specific section flags. Okay, so that fills in our list. And then PE, yeah, we just need the thing that goes like this. So we go get a scratch, fill in the list, elf straight list from section flags, list flags, join flags, straight join flags, arena, list, result, release scratch. There we go. Oh, right, we didn't want to give the flags a type def because they're not always the same size. That's fine. Okay. So I'm still not using the new flag strings, so let's go do that. String 8 flags string equals elf straight from section flags. Here I need to drop in the section flags. Flags string. What? Ah, right. This needs to become this. Alloc, 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 alloc. Ooh, alloc info link. Interesting. Info link. Exec inster. Alloc, exec inster. Adder. Adder. Exec inster. Exec inster. Exec inster. Good question. So the question is, my editor doesn't, if I start typing something, it auto-completes without a pop-up. The answer is I hit tab to autocomplete, and if I don't get what I want, I hit tab again, and it gives me the next thing in an invisible list. So if the first thing isn't what I want, I can tab a couple times and see if what I'm looking for will show up. I can also go like, oh, this isn't quite what I want. Like, let's say I type M4 and I start going, I'm like, this isn't what I'm looking for. Let's type that much, and then I get the list of things that are that long. If you want the list, there's another way to do it where you go, how have I got it bound? Is it, I'm forgetting the command for this right now. I don't use this very often, or pretty much ever on purpose, but like, let me look at, I'm just going to go to the command lister and see what is bound to real quick. Complete, drop down, tab, Control Shift Tab. Okay, so if I do Control Shift Tab, then I can get a lister here of all the options and use an F key to complete it. So I can go like, oh, there we go, F5, boom, right. But usually I just am hitting tab and looking through the options manually. Yeah, the nice thing is 90% of the time, and it also, it determines the order of what matches to use, right? So if I type M4 and tab, it'll always grab the nearest thing. So wherever the nearest instance of M4 is, it matches that and completes to whatever was there. So when it generates the list of all the possible matches, it starts by doing a wavefront search from the current position in this file to find the nearest spots. Then it goes through all the other buffers that are open. So it can match across an entire project, and it uses the most recently modified buffers come first, with the current buffer being at the top of the list with a special wavefront search. So it's always trying to match whatever is most likely the thing you just used in a completely stateless way. It's just deriving the list from where you're editing, which means it doesn't get into weird states very often. Occasionally, you can predict exactly how it'll behave, and that can be very nice. And then on a few occasions, it doesn't give you what you want without a bunch of tabbing, and that can be annoying too. There is a downside, but 90% of the time, it hits the hot path of like 1 or 2 times to hit tab, and your flow never breaks. Okay. So we're almost done. All we got to do is go and research link and info again, remind ourselves what those mean. Link. This member holds a section header table index link whose interpretation depends on the section type. This member holds extra information whose interpretation depends on the section type. Okay. So those are just extra fields that are they're sort of Lego bricked. They mean different things depending on the type. Yeah, I don't know. I've never worked with an LSP before. And so, like, one thing this doesn't do, like, is if I do this, it doesn't know how to, like, it doesn't have any semantic information. So, you know, if we were to track down the definition of this type, there's a string and a size in there, and an LSP would be able to just tab complete those from this if it was smart. But I don't know. My current customization, like other people who have used ForCoder have added a bunch of customizations that can do more code intelligence kinds of stuff. I've even seen people do like tree sitter and LSP integrations, but I just run stuff that is entirely text based. It just runs on the level of text. It doesn't do code analysis, and it turns out that can get good enough that I'm happy. And I like how predictable it is. It never gets clunky. It never like screws up because of subtle funky language parser problems or anything like that. Okay. Okay, I think sections are done. So let's try to go and dump the segments. Need to track that down. We also need to track down how to parse out the symbols. We don't have a symbol table working yet. We have symbol table. There's a string table foff, I know. Section table foff, string section. Oh, there's a section, right. So there's no symbol table. Yeah, so we need to figure out how to dump a symbol table before the end of the day too. We have relocations, but here we go. Let's do segments. Okay, all of this is pretty much identical. Segments and sections work in very similar ways. We just use the segment size, segment count, and segment table foff. And then instead of sections, we're looking at segments. And then not sections, segments. Seg isn't short for sections. Section count? No, not section count. Segment count. Okay. Segment's good. Okay, so we've got almost everything, but we're gonna need these decoder functions, the ones that convert us, or the normalized functions, I should say. We need elf segment 64 from segment 32, elf segment 64 dest, elf segment 32 source, elf encoding, source encoding from segment 64, boing, 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 elf section 64 from section 64, boing, here's that. Okay. Next up, we want to start with something like that, but we want to look at the segment types, which are living right here. Okay, so this one is exactly correct. Type goes like that. Now let's see, offset equals elf u32 decode offset. Type to type, offset to offset, vadder to vadder. Padder to padder. Ooh. File siz means file size, and memsiz means memory size. Are there any other bad abbreviations? Okay, that'll work. Padder, file size to file size, memory size to memory size, flags to flags, align to align. Let's go check out this network gives the virtual address at which the first byte of the segment resides in memory. On systems for which physical addressing is relevant, this member is reserved for the segment's physical address. Because system D ignores physical addressing for application programs, this member has unspecified contents for executable files and shared objects. This number gives the offset from the beginning of the file at which the first byte of the segment resides. Okay, got it. We're going to just ignore that and keep going. This seems irrelevant to my interests. Okay. Okay, so good, but this needs to come from here. Flip order becomes a 1. Flags. Padder, file size, memory size, align. Still talking about seggen count, huh? There we go. Okay, so type string gotta get that set up. New line. Flags equals flags offset OX percent LLX 08 V adder P adder file size memory size Ba-da-bum-bum-bum. Align. Okay, segments. Ooh, okay, so we are forgetting that extra new line at the end of each chunk of the dump. Sections, segments. Wow, so many segments too. Okay. Section types get replaced with segment types. Section types get replaced with segment types. Low OS, high OS, low proc, high proc. No user range on this one. segment type xlist. That's all those. All right, our segment types. Oh, we don't have them in the dumper yet. Elf straight from segment type, Badink, boom, boom. Putter, interp, load, dynamic, note. OS, custom type. Boom. OS custom type. Bunch of annoying GNU nonsense. Gotta figure out. Oh man, this is the ELF format itself. Isn't a problem, but the amount of nonsense that goes through the Linux ecosystem's object files and executables is a problem. So the format is simple, but the number of mini specs that all come together from all over the place to get their hands in the game, or get their fingers in the pie, whatever you want to phrase it, whatever metaphor makes it clear what's happening. It's too many little bits of disparate design packed in there at the same time. And that's what all of this is. Okay, let's do the flag mnemonics. Flags string equals elf straight from segment flags, scratch arena, segment flags, link. Okay, segment flags xlist. Again, it's 20 bits of good flags, followed by the masks for the OS and processor specific custom flags. And then all of this is wrote for this. There's our flag mnemonics. Read, execute read, write read, write read, write read. There you go. Yeah, Steffi is asking how to use forcoder to delete a rectangle of code. Okay, a couple of comments here. One, forcoder default layer doesn't actually have something exactly like what you're asking for. I think I might have experimented with this stuff once upon a time. Let's take a quick look. Um, yeah, I don't think... Example, let's go track this down real quick. We've got the 4-coder code sitting around. Custom layer. Examples. Right. So... yeah, I thought that's where I put it, but I guess maybe I didn't have this in the end. Okay. Um, so there's no built-in way to do it in the custom layer, not even or in the default custom layer. I'm sure other people have built customizations that have that built in, but here's how I would do the same kind of effect. Say, let's pull up a good table somewhere. Where do I have a good table? Okay, let's say you're looking at this and you want to just delete all of this entire first column of this X list here. All I would do is begin a macro, hit Control Space and record deleting one line, go down one, end macro, and then repeat the macro. So I don't have built-in rectangle editing, but I can do repeated application of a sequence to quickly handle stuff like that. And that's how I prefer to do it. So I hope that helps. If you really want a rectangle selection, go look at some custom layers other than mine. You know, go over to the 4-coder Discord and ask, because I'm pretty sure other people built that. I remember seeing it once upon a time. Okay. All right, we did sections and segments. I'm going to take my 5-minute break. And when we get back, maybe try to track down symbol table stuff. But sections and segments are the main structure after the header. So those are the two big ones. We got those done. And we're just filling in the last few details that we actually can do without getting more specific. Let me set up my break. Let's get this just right. There we go. Perfect. I'll be back. Alrighty. Okay, let's see if we can get those symbols coming out too. And maybe relocations also. Name, info, other. Function index value size. Yeah, okay, got it. So where do we find these? That's the other question we need an answer to. An object file symbol table holds information needed to locate and relocate a program's symbolic definitions and references. A symbol table index is a subscript into this array. Index 0 both designates the first entry in the table and serves as the undefined symbol index. The contents of the initial entry are specified later in this section. Okay, so this is where you tell me about the symbol types. How do I find the symbol table? These sections hold a symbol table. Currently, an object file may have only one section of each type. This restriction may be relaxed in the future. Okay. So let's dump SymTab. So if we've got sections, then we're going to scan across our sections. And we're looking for a section whose type is elf section type SymTab. Okay, that's escape hatch for 60 or 32-bit section indexes. Makes sense. It looks sort of like this, although this time it might be different. So we need to calculate the symbol count, which is going to be the sim tab. You know what? This needs to come up here. Sim tab symbol count, right? And then it's going to go right here. Sim tab symbol count is the sim tab section size divided by the size of a 32-bit symbol, and this is divided by the size of a 64-bit symbol. Sim tab symbol count okay, so we want to do elf symbol 64 from symbol 32, sim tab plus I, sim tab 32 raw plus I, elf encoding, sim tab 64 raw does not equal 0, same basic idea, but now reading from the 64-bit raw, and otherwise the sim tab is not good anymore. All right, that should give me my symbol table. Okay. Okay. We want symbol equal to sim tab %u equals that. That will be like that. That will go there. And name equals %s, comma, string 8. Name equals straight lit to do. Type string. OX %. LLX. %s parenthesis. OX %x. Yeah, not LLX, X. So that's type string. Here we got name type string. Symbol type. Flags. OX 08X %08X. Symbol flags. To do flag mnemonics. Adder. Offset. Size. Oh, I'm reading off the wrong one here. Flags. Adder. Offset. Size. Wait, this is just section. Where is symbol? Okay, so this was all wrong. This is all garbage. Very good. Let's start from info, other, section index, value, size. Let's do that. Okay, here we go. No type string, no flags mnemonics. What we really have is other. Actually, what we want to do is break these down even more. So info has a bind and a type. Let's put both of those in there. Yeah, info, other. Just, okay. One thing at a time, Section index, value, and size. Okay. Name, info. Okay, so info is going to be broken up into a bind equals bind string, not info string, I'm looking for type string. Type string, viz string, section index, value, size. No Indianness when you just have one byte. Okay, but let's get these in the right order. Name, info, other, section index, value, size. There we go. Okay, so we have our symbols. But we need to get all these mnemonics working or we can't do anything with it. So, name. Where does the name for a symbol come from? Island Dude asks, are you making your own elf dumper parser? That's right. I'm starting with an elf dumper and just working on just the basic structures like section, segment, symbols, relocation information. And then once that's done, I'll shift over to trying to make an elf generator so we can arrange an elf file from its component parts more easily. I already did the same thing with PE Cough. I don't know if you... it looks like you're new, so I'm just pointing out this is a long ongoing project that we've done. We've done one iteration of it on the Windows side of things already. Okay, this number holds an index in the object file's symbol string table, which holds the character representation of the symbol name. If the value is non-zero, it represents a string table index that gives the symbol name. Otherwise, the symbol table entry has no name. Symbol string table. Okay, so we need to find the symbol string table. Stir tab. This section holds strings. Most commonly, sections attributes will include the alloc bit. Otherwise, that bit will be off. Since the names associated with the symbol table entries. Yeah. It is for Windows. It's also well, like I'm working on a cross-platform object file project. So I'm supposed to just look for a section with this name? Okay. I think there was something else. There's like, if I look at a section, the associated string table. Okay, so I can use the SymTab section, link one greater than the symbol table index of the last local symbol. Okay, and info is the count. Okay. Symbol table count. The SymTab section info. In theory, that should do the same thing. Oh, but it stopped sooner. Interesting. Well, who knows? Maybe that's the right thing to do. So, the other thing we need to figure out is where is our string table? U8 SymTab string table first, one past last. There's our string table section, and then the SymTab string table first is just input data.string plus string table dot offset, and OPL is just first plus string table size. Okay, and then name sitting over here. We want to do a C string capped on SymTab string table first plus symbol name SymTab string table opal. That should get us our names. Nice. Okay, so our symbols are, oh, we want to put quotes on strings like these. So an empty string, secret1.o, Abby tag, kurtstuff.c, deregister to clones, register to clones, do global detours aux, completed.0, do global detours aux fini array entry, frame dummy init array entry, test.c, kurtstuff.c frame end, blank dynamic GNU frame header, global offset table. And that's it, huh? That's all of our symbols. Let me just run a little experiment now. What if this is garbage and the right way to get the symbol table count was what we were doing before, where we take the size of the section and divide by the size of each symbol. Because the stride here is definitely right. We're getting names where we're supposed to get names that make sense. That doesn't seem like, I don't see anything fishy here suggesting that these are not actually strings or that these are not actually section indexes. So it's not a stride problem. No, it's the same number. I thought there were more. Okay. In that case, I think what we should do cap, extract symbol count, symtab symbol count equals clamp top, symtab symbol count cap. There we go. Alrighty. Symbol binding. Symbol bind from info. Symbol info. Type from info. Symbol type. Elf. Symbol visibility. Viz equals elf. Symbol viz from other. Symbol other. Elf straight from symbol bind. Elf straight from symbol type. Elf straight from symbol viz. We need those guys now. Boom. String 8. Elf straight from symbol binding. Elf symbol binding. Type from symbol type. Viz from symbol viz. Bingo. Bongo. Get each of those going. Alright, symbol binding X list. What do we got here? Simple enough. Hios. We want one of those. Loop. Segment type is replaced with symbol binding. Loose, Hios, Loproc, and Hyproc. Proc custom type, OS custom type. And segment type, of course, just gets replaced with bind. That goes there. Symbol binding xlist. And there we go. Type. Symbol binding gets replaced with symbol type. Bind gets replaced with type. Cool. Okay, so that's SimTab, but if I remember correctly, we do have a DinSim too, and DinSim here's a question, is SimTab SimTab's looking at number 29 StirTab. Okay. 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 So let's go to our dumper, and everything we do with SimTab is perfectly good, but we want to do it all a second time for DinSim. So that's a lot of code to duplicate. Let's try to dedupe some of this. Okay. So sim32 raw, sim64 raw. Symbol count cap. Symbol table count. Symbol count cap. Okay, so we filled the count, the string table is like strings. Then we just have to normalize like this. Elf symbol 64 symbols. What I'm actually going to do is fill string table first, local variables, and then fill the symbol table struct at the end. Symbol count. Symbol count cap. Symbols. Fill symbol table. Symbol table. Symbols equals symbols. This will be if symbols came out good, then we actually will fill it. But if not, then we can leave the whole thing nulled out. That's why we are not filling it as we go. String table first. String table first. Opal. Opal. There we go. Now that should break. Oh. Okay, there's some compilation errors here still. Sim32 raw, sim64 raw, simtab, sim32 raw, sim64 raw. Symbol count. Symbol count. Symbol count. Symbol count. Symbol count. Boom. Okay, so if simtab symbols does not equal 0, then we're looking at the simtab count, simtab symbols plus I, simtab string table first, last symbol name, symbol blah 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 blah. Very good. So that's how we do it for simtab. But now, let's do this. Symtab. Right, so we're going to do symbol tables, string 8 symbol table name. Symbol table name 0 is Symtab. Symbol table name 1 is DinSym. And we'll hit another for k loop. We actually just don't need these, do we? We might want them later, but it'll be fine. It's fine. Make sure that gets cleared to 0. Okay. And then all of this is a part of the for loop. Elf dump symbol table equals symbol tables k address of symbol table symbols does not equal 0, then symbol table count symbol table symbols symbol table string table first. Okay, let's pull that down a line so we can see it better. That should work. Now this has to change. That is now the symbol table name k. There we go. And we got Symtab and DinSym. DinSym only has the null entry apparently, but that's fine. Okay. Well, that's been about 2 hours of work. We did sections, we did segments, and now we've done symbol table and the DinSym symbol table. So I think that's a pretty good amount for today. The stuff I didn't get to yet is relocations, and we haven't tracked down any of the special meanings on things like these that might be worth knowing about, but we didn't do that on PECOF either. So I think that this is a good amount of progress. Now we can wrap this up for today. As I'm signing off, I'll give you a quick reminder that all of this work that I am doing with the elf dumping and the PECOF stuff, the Bindash project that I've been working on some of my other streams, all of that is a part of the Mr. Forth Lab project. I am working on practical research things that I think we can do better on that will make a practical difference on how we program. And if you would like to support me so that I can keep doing this long term, I would appreciate it if you go to mrforth.com/membership and check out the options. You can do a monthly support or a yearly supporting schedule, and there are different tiers here, so you can get whatever perks you want in exchange. I think some of these are pretty cool. We just finished indexing the 3rd series of graphics videos, so this has gotten, the video index library is getting bigger. And we're going to do a few more, the video essays and stuff still need to be indexed, but we're getting there on that. And besides that, I will see y'all around the internet. Thanks for checking out what I'm working on, and later.